Okay, Jan has some metal that she's going to make into solid metal spheres. Each sphere will have a radius of 2.15. She has 1,490 centimetres cubed of metal. Work out an estimate for the number of spheres she can make. So the first thing we need to know is how to calculate the volume of that sphere. And then when we know what the volume of one sphere is, we can try to calculate how many spheres she's able to make, knowing that she starts with that amount in the first place. Okay, but the other keyword that you need to figure out is that they are saying estimate. So it's unlikely you're going to be able to do it accurately without a calculator, and estimation is such an important skill. So we are going to be rounding these values before we use them. Okay, so instead of 2.15 for the radius, we're just going to use 2. The formula is using pi, so they assume that you know that pi is 3.14 something. So we're not going to use that, we're going to use 3. Okay, because to use that would be ridiculous. So I'm going to use those values now to calculate the volume of one sphere. So 4/3 pi times the radius cubed. Okay, so that's what we've got there. You can do a quick shortcut if you've got a fraction in a chain of multiplications and you've got a denominator that's the same as one of your numbers. You can cancel them out like this. So they've gone. Just leaving a simple calculation of 4 times 2 cubed. So 2 cubed is 2 times 2 times 2, not 2 times 2 times, yeah, that's it. So that's going to be 8. So the volume of a sphere, just one of them, is 32 centimetres cubed. We're told that we've got 1,490 centimetres cubed to start off with. So I'm going to change that to 1,500. So that's our total volume. That's the volume of each sphere. And we're going to try and figure out how many we can get. So when you're thinking in terms of how many, you're thinking divide. So we're going to divide 1,500 by 32. Okay, some of you may know long division. I'm still going to stick to short division. So that's what I'm going to do. You just keep adding 32. I'm just going to cheat because I did it wrong. But taking your time, adding 30, adding 2, just to make sure that these are done right. What I could do, I could even estimate it further and change this 32 to 30 and know that I roughly should be getting 1,500 divided by 30, so it's going to be about 50. But if I'm just going to keep with this calculation to be a little bit more accurate, I can. So there's my times table, my 32 times table. So 32 goes into 1, no it doesn't, carry 1. 32 doesn't go into 15, so 0, carry 15. 32, look down your list, you've got 150, you can't go over it, so we're going to go to 128, so it's going to be 4. If I wanted 150, and I've got to 128, you can take them away. It means the remainder is 22. So now I need to figure out how many 32s are in 220. You can see you've got 224 there. So I've got 1, 2, 3, 4, 5, 6, but 224 you can't go to. So I've got 46. Put a decimal point in, carry the calculation with a 0 on, and then do the remainder of 4. And then I've got 1. But that'll be enough really, because I'm doing an estimate. Knowing that roughly I'm going to get 46 spheres will be enough for this one. Okay? It says if you calculate the number of spheres accurately, how do you think this will change your answer? So you've got to look at the type of calculation that you're doing. The calculation we've done the most rounding is the volume of sphere, and you round everything down. Okay, so if we did it accurately, the volume of that sphere would actually probably be bigger. So if we're going to divide by a bigger number, the answer is likely to be smaller. Okay, and it's kind of like those upper bound and lower bound questions where you're trying to see what the impact of a calculation is. So if you divide in by a bigger value, then the answer is going to be smaller. So that's what's likely to happen. So you will get a smaller answer. As you divide in by a bigger number. Okay. Right, so I'm going to show you two approaches to this calculation. So one way you're kind of thinking more like an A-level student, now you break numbers down to their powers before you do it, and one way you just calculate this as a big value and then try to thought through it. So the A-level approach is where you're going to break 27 into 3s as a power. So that's actually 3 to the power 4. Or was it 3 to the power 3, sorry. Yeah, that's 3 to the power 3. So when I consider this again, the thought through of 3 to the power 3 times by 3 times 10 to the power 8, these two 3's will actually combine to be 3 to the power 4. and you've got 10 to the 8. If you really think about the fourth root as an actual power, if we change it to a power instead as a root, we know that's going to be power of a quarter. So that's what I'm going to do. And when you've got a power on powers, we know that we'll multiply them. So you've got 3 to the power of 4 to the power of a quarter, that will just become 3. Then you've got 10 to the power of 8 to the power of a quarter. When we multiply that, that will give me 2. So in the end, that calculation boils down to 3 times 10 squared, which is 300. So that's more of an A-level approach where you're breaking the numbers back into numbers with powers. And it was obvious that they were going to generate a power of 4 because they had a fourth root on the outside. The other way, which is going to work definitely, is figuring out 27 times 3 to get 81. And then knowing that 10 to the power of 8 is going to give you those 8 zeros. So you've got 8, 1 with 1, 2, 3, 4, 5, 6, 7, 8 zeros. And we're going to do the fourth root of that value, which is 8 billion-ish. But you don't think in that way. You think, what is the fourth root of 81? So what number do you multiply by itself 4 times to make 81? If you can't do that, you literally have to start by writing out 1 times 1 times 1 times 1, 2 times 2 times 2 times 2. And these values will grow so rapidly, it won't take you long to find it. Okay, so 2 times 2 times 2 is 16. So 3 times 3 times 3 times 3, 3 times 3 is 9, times 3 is 27, times 3 again is 81. So you can see doing that basic way reveals what the value will be. So that's going to be 3. And then if you look at the zeros, a very basic way to think about it is if you can chunk them into groups of 4 groups like that, which I can do there, you're only going to have one of those groups left. So that's how you can generate 300 that way. It's an awkward question, deliberately so, and it's not been presented to you like that before. So there's 2 approaches to it. If you do try and go the A-level route and break 27 down to a power of 3, you're going to get credit for that. Right, this one, you've got a power of minus 2/3. So I keep trying to get you to understand that the bottom of a fraction or fractional power is the type of root you've got to apply. The top of the fraction is the type of power you've got to apply. And a negative fractional power or negative power is just code for how you manipulate the answer to that. So if it's got 3 as the base of the fraction, that's going to be the cube root. So we're going to cube root these values. And if it's got a power of 2, if it's got 2 as the numerator, you're going to have to square them. Because it's a fraction, you're going to have to do the same to the top and the bottom. Like that. And I haven't actually calculated anything right now. I've just showed him that I'm going to cube root it, then square these numbers. So I'm going to get credit for that. So the cube root of 216. Same approach for this one. You can write out your cube numbers, okay? But I know the cube root of 216 is 6. Cube root of 1000 is 10. So I'm going to square those to get 36 over 100. And that's me just dealing with the fractional power. Now I have to remember that it was a negative power. If it's just a negative power, normally it's 1 over the value, which is the reciprocal. It's where you flip the fraction, really. So we've actually got a fraction now. So we're going to flip that fraction. So it's 100 over 36. It's really tight for 2 marks. I don't reckon in the real exam it's going to be 2 marks. But this is by Excel, so you never know. You don't know how they're going to allocate the marks. I would suggest that that could be up to 4 marks with the amount of steps you've got to do. It just depends where it's placed within the paper. Oh, this likes to in. Anyway, next one. This is a nice question to have. It's worth 4 marks. You can get steps all the way through, even if you naff up the first step. Okay. So with rearrangement, you have to decide on your approach. So my approach is, because I've got 2 letters, first of all, they can't be in a fraction, so I'm going to have to eliminate this fraction, but then they all have to be on the same side. So I'm going to get rid of this t over t minus 3, because it's the base of the fraction. I'm going to multiply by that. So the k is going to be multiplied by t minus 3. But when you're rearranging, you've got to think of all. And what I mean by that is when you're multiplying, you multiply all of the other side by that. If you divide in, you divide everything, all of the other side. Because if you don't, and you just multiply the numbers you can see or whatever, you will not be doing it correctly. So we've got that. And I keep going on and banging on about this, when you're rearranging formula, if you see a fraction, expand it. So don't try to break this down. Do not try to remove this 2. This 2 is for you trapped now by that bracket. So you're going to have to multiply these brackets. So you've got kt minus 3k equals 2t plus 6. But now, and so that's it. That's the next step. So I've got 2 now, and I've done very basic maths there. I've done hardly anything really. I've moved that across here, and I've expanded some brackets. Now the dilemma is that I've got t on either side, and that needs to change. So I want everything that I'm after, all the t's that I'm after, needs to come to the left, and everything else needs to go to the right. So this minus 3k, I'm going to eliminate that by adding 3k. So kt equals 2t plus 6, add 3k. And now that 2t here can go to the other side by taking it away. So take away 2t. So kt minus 2t equals 6 plus 3k. So all the letters that we're after, or the letter we're after, the letter we're trying to make subject to the formula is now all on the left. But another problem now is that it's in 2 things. So we've got kt minus 2t. So we need to extract t from both of them. We need to make just one lot of t. So to do that, we're going to factorise. So t is common to both those 2, so it's on the outside. Leaves k minus 2 equals 6 plus 3k. And finally, we've only got one lot t, but we've got this bracket next to it. So therefore, we're multiplying. To get rid, we're going to divide. So we can divide by k minus t. So t equals, and this is the divide element, divide everything. So when you're dividing in rearrangement, just draw a big fraction. K minus t. There we go. So there's loads and loads of steps, and obviously some of you will combine steps within one, but all these separate parts where you can see there's 4 clear steps from me, that's why I'm going to get 4 clear marks. Okay, so if I did mess up the first step here, but I tried to get everything to one side, I would get credit. So it's very important you do that. Right, this is a trick question. Again, it's kind of more like an A-level question where they're trying to get you to look at something by inspection, to look at the expression and try and think differently. So it's asking you to factorise this expression that looks already factorised to you guys because you wouldn't have seen it in this way. But if you think about factorising clearly, you take out what's common. Okay, so what's common to this is that the bracket x minus y is in both of them. It just happens to be that you've got a square one there. So let's do that. Let's take out x minus y. And let's just think about what we've got left. Okay, so if I take that out of here, that square will then just be, so we've got 3, because that 3 wasn't the one taken out, but we had that bracket twice. We've taken one of them away, so we've got that there like that. And if I remove xy from that, I'm going to be left with this. It looks a bit awkward with this bracket within inside a bracket, so we're going to keep the first set of brackets, so x minus y, and then expand that to make it 3x minus y, 3y minus 2. Okay, so it has been factorised. Okay, just a weird one. Some of you were trying to expand this and then try to boil it down to a quadratic and so on, but it was much more straightforward than that. It was this one. Okay, show that 1 over 2x squared plus x minus 15 divided by 1 over 3x squared plus 9x simplifies to ax over bx plus c. So basically, can you calculate algebraic fractions? So when you see algebraic fractions, the first thing you need to think about is, can I factorise it? Can I simplify it? Can I make it an easier question? So that's what I'm going to attempt to do. Okay, so I can see that quadratic on the bottom, and the reason you can recognise a quadratic, it goes squared, then the power of 1, and then there's no x at all, so the power of 0. Okay, so I'm going to do front times back, split in the middle, factorise. Okay, so that's what I'm going to do away from the fraction work. So I'm going to do it down here, this empty space. So 2 times minus 15 is minus 30. Factors of 30, 1 and 30, 2 and 15, 3 and 10. 4 don't work, 5 and 6. 6 is a repeat, so I've definitely got all the factors. Because I've got this negative product, because I've got a negative answer here, we're thinking what is the difference between these values. Okay, so I'm going to take the 2 values away for all these pairs, just to highlight what I'm looking at. So I've got 29, 13, 7 and 1. Because the middle term is just x, that is 1x, I'm going to select 5 and 6 because they have that gap of 1. Okay, so that's what I'm going to do. I'm going to split x into, well, I need positive x, so I'm going to have negative 5x plus 6x. And remember to put the negative first will help with not having to take a negative factor out. Split down the middle, factorise the left, factorise the right. And this is why I prefer this method, because you can see that bracket is the same, so we know we're on the right track. So we've got 2x minus 5, x minus 3, and that can go back into the fraction. Oop, like that, divided by. And here, I can see that I can factorise it, but it's not a quadratic expression because there's no number. So there's nothing there. So I'm just going to factorise normally. So we've got 3x squared plus 9x. You've got 3 times tables, that's coming out. You've got x clearly in both of them. And you should know that you're on the right track because one of these brackets is going to repeat itself. So 3x into 3x squared is x. And then we've got 3x into 9 is that. So we've got 9, so it's 3. Okay, let's get that. Okay, so when we do these, remember that we're going to flip the bracket, so flip the end fraction and multiply instead. Okay, and now we're multiplying algebraic fractions. We should be able to cross cancel. Okay, so that's what we're looking to do. Oh, that's plus that one. So we can cross cancel these brackets here. Sorry, it's out of the way there. Which leaves 1 over 2x minus 5 times by 3x over 1. We'll multiply fractions, tops times tops, so 3x, multiply the bottom, 2x minus 5 times 1 is just going to stay the same, so we get that. Just like that. Okay? It is straightforward when you know how to factorise because you're following the rules of fractions. If you showed the examiner that you flip this fraction in times instead, you would still get a bit of credit for that. You would be able to factorise the easy one and get credit for that. So if you're not confident that you're going to be able to get all the solution, pick the parts you can get easy marks from.